You have to do 9 and 10, right? And you'll have to look for the mean, right? And the mad. Mean absolute deviation. And what was the mean for Austin? 31? 31.85. And what was the mean absolute deviation? That? What about for San Antonio? What was the mean? 34 point what? And what was the mean absolute deviation? 30 and then 459? What was the mean absolute deviation? That? Did most of you get that one? Okay. Uh, yeah. What else did I ask you to do besides this? That's good. All right. Again, just a quick review. To get the mean, you add all of these up and divide it by the amount of numbers. To get the mean absolute deviation, the MAD, you figure out how far these numbers are from the mean, and you add all those distances together and divide it by the amount of numbers, right? It's just an average of all the distances. That's it. I'm not going to give you a grade for that one. I just want you to practice because it wasn't for the first period. We're going to move on to financial literacy. I was looking at some of the stuff that you guys are going to see and the things that you're not going to see. So I know last class we had not a problem. I just did not know exactly how far we needed to go. And this unit was completely done on line. Like all of this, you have to do it using a calculator, online calculator. So your online calculator is this one, and I'm gonna set the link on Edmodo so you can use it for your homework, part of your homework, because I need you to practice on it, just so you have an idea of how it works. So again, using this example that we had on the book, we're talking about a loan of $1,000 with a term of 3 months and a rate of 21% per year. And literally you grab these things and you plug them into the calculator. $1,000. The term in years is 0.25 because we only have 3 months, right? So 3 months out of the year, when you turn it into a decimal, it gives you 0.25, which the term tells you, or term in months. And then the interest rate, you plug it in, you calculate, and it gives you 345.7. 0.07, which is exactly what it gave you here. Then you multiply by the month, and it gives you the total amount with the interest. So you use the calculator to figure out how much is going to be the payment per month. Kayla, over here. You use the calculator to figure out how much you're going to pay every month with a given rate. And then after you do that, if you want to know how much you're going to have to pay for 3 months, then all you have to do is multiply by 3, and it gives you this. Now, obviously that is more than $1,000, right? Because we're including the interest. The interest, again, is the cost of lending and borrowing money. So to figure out how much you're paying in interest, you just subtract those two, and it's right here. That's it. That's all there is to it. It's not a very difficult concept. But I don't think you're gonna see. There's no way you can see it from the start because you cannot access an online calculator while you're testing. However, you will be given this information, and you're gonna probably be asked to make inferences. Well, what would it be? How much will you have left, or what will be the balance after 2 months? And what would you do if that was the situation for this one? I actually asked you this question specifically for those of you here moving around not paying attention. If this wasn't going to be on there, I wouldn't waste my time on it. This is for you, so that you actually are better prepared for this test. So please pay attention. Give me your time like I am giving mine. Okay? You're not going to see this in the exact same format, but you will be given the information most likely if it's on there. They're going to give you all this information. Tabaria over here. This right here. How much you're asking for the loan, the term, and the interest rate. And how much you're paying every month, which is just over here. Monthly payments. And then once you're given that, you might be asked to make inferences. Well, what will be the balance after 2 months? Continue. You just seem to have it right. Okay. You find a difference, yes, but nobody can hear you. So you multiply the monthly payments of 345.07 by 2 months, right? That gives you a number. Take that away from the total amount that you got when you multiply by 3, and that's going to give you what's remaining, which should be that actually. It's not really difficult. I'm going to assign you some homework on this one, and I will post the calculator also on there, and it'll be this one right here, number 4 and number 5 on the following page. No, you're going to have 4 more. Number 4 and 5 on page 442. Wait, was it that one that I gave the kids? I think it was. No, just 4 and 5. All right, so this is the next part we're doing. We're going to go over simple and compound interest. Simple and compound interest we covered last semester. Not in much depth, but we did. For both, you will have a formula, so you don't have to worry about remembering the formula because it'll be on the formula chart if it's going to be on there. Aaron, what's going on? Okay. So we're going to fill out this table. Basically, the formula is the interest that you're paying is going to be the principal times the rate times the term. What is the principal in any situation? What does the word principal mean in this situation? Wow. Yes, the principal is our school principal. The mean. Wow, the mean. I want you to focus on these things, guys. I mean, I know you're tired and blah, 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 but come on. Thank you. Somebody's reading. Somebody's paying attention. Yes, the original amount, whether you're getting a loan or lending some money, that's going to be it. The principal is the first amount, the initial amount, whatever you start with. If you're saving money and you deposit $1,000, that is your principal. If you're borrowing money and you're borrowing $2,000, that is your principal. The rate is always given. It's a percentage, an interest rate. And the term is the time that you're going to have this loan for or this savings account for. That's it. It's very simple. Do not lose me on this. So let's read the question. Adam makes regular deposits to a savings account to save money for college. He deposits $1,000 at the start of each year into an account that pays 4% simple interest at the end of each year. He does not deposit the interest. What is the difference between this guy who's depositing money and getting paid interest and another guy who's borrowing money from the bank? Yes, the person who is borrowing money has to pay it back with the interest. And you are saving money, so why do you have an interest? Well, that's not the point of a savings account. What is the point of a savings account? Basically to save your money, right? Well, this one is a college. It's for college. So you save that money in this context, $1,000 every year that you put in the bank for college, and it earns interest on its own. It grows on its own. Yes, and then yes, you can pay for college. Basically, yes, but you also get interest for having that money in the bank. So just like you borrow money from the bank, the bank also borrows money from people. Whenever you open up a savings account, that's what it does. So all they do is they pay them an interest for having people go into the banks, to their banks, and leave their money there. That's what it is. The monies don't actually generate money. They interchange. They just borrow from you, then I pay you, and back and forth. But they're like a mediation of people, people who are borrowing, people who are lending. Uh, so in this example, we use the formula of I equals PRT. P obviously again is the principal, whatever money you started with, 1,000. The R is the rate, 4%. Now, don't ever plug in a number in percent format into a formula. Turn it into a decimal. So what would it be? 0.04 times 1. Why did it choose 1? It's 1 year. The last number represents a term, and we're talking about 1 year. So on your calculators, calculate the amount of interest that this person would earn in 1 year. 40. That's just about right. 1,000 times 0.04 times 1 equals 40. So Aiden's account earns $40 the first year. And that's basically how it works. If you had an account that earned interest every month, then it will grow every month. Credit cards generally well, they don't earn interest. They charge you an interest every month. So, yes. The percentage does not change. What changes is just the total amount of interest at the end of it. You'll see in a minute. When we go over this table, we're going to fill it out, and I'll do the first read with you, and I'll let you do the rest of them. So for number 1, at the beginning you had $0, right? Then you added $1,000, and you ended up with 1,000, right? Then you plug this number into the interest, and then it gives you $40 that you earned. Now that for the next month, you already had 1,000, right? Because you're not including the interest. And then you add another 1,000 and you get 2,000, right? Do the same thing, plug it into or you can just change the term, and it gives you 80, right? Then again, you start with $2,000 now, and then you add another 1,000 because you're adding every year. Now you have $3,000, which is in your third year. By that third year, you have already earned $120 on interest only. You have not added this to the equation, the interest on the side. Now we have $3,000. We had $1,000. What do we have here? $4,000. 160. How do you figure that out? You adding 40, you see in the pattern. That's good. I want you to understand why that is, though. All you have to do to the equation is change the year. That's it. And it gives you the amount. That way you don't have to go through each of them and see, well, where's the pattern? Because if you go by the pattern, you're going to have to do all of these to get to the very last one. That makes no sense. But you can just plug it into the calculator, and instead of putting 1 here, you put whatever term it is. After whatever year, you put it in there. The T represents a term. Do not forget that. I will let you complete the whole table on your own. Go. I'm thinking. So then this will be 4,000 plus that is 5,000, and the rate will be 200. Then 5,000 plus 6,000, 240, and then 6,000 plus that, it'll be 7,000, 280. And then 7,000 plus 1,000 is 8,000. It'll give me 320. 8,000 plus 1,000 equals 9,000. 360. And then 9,000. $400. Fairly easy. So how much interest did Aiden's account earned from the initial deposit to the end of year 5? How much interest did he earn? What? 160? To the end of the 5th year. You go to year 5 and you look at the interest, and he earned 200, not 160. That's at the end of it. It's 200. All right, from the start of the year 6 to the end of year 10, how much was it? What do you do to figure that out? It is not 400. Yeah, subtract 240 from 400, right? That gives. It's only from the end of year 6 to the end of that year. Oh, from the start of year 6, sorry. That's it. All right. Blah, blah, blah. The next one is compound interest. This one I tried to explain last time, that you have to redo the whole thing over and over and over again. You really don't. You actually have a formula you can use for it. So for this one, it's a different type of interest. We have simple interest, which is pretty easy to calculate, and then we have compound. I'm sorry. The following page. I mean, you would think that you just flipped. All right. So for this one, it would be A equals P times 1 plus R to the power of T, where this is the principal again. 1 is just 1, a number. R is the rate, and T is the term. So Lily makes regular deposits to a savings account to save money for retirement. She deposits $1,000 each year, and her account earns a compounded annually rate of 4%. It's very similar to the other one, but this one is compounded, not simple. So we use the formula. 1,000 times 1 plus the rate of 0.04 to the power of 1 for 1 year. So go ahead on your calculators and figure that one out. So we got 1,040, right? So when you subtract 1,000 from 1,040, my goodness, this thing keeps moving. What do you get? Subtract 1,000 from 1,040. So that means that you earned $40 after your first year, right? That's it. All right. Notice what happens, though. I told you that for this one, it's not as easy. You have to use now what you earned that year to move on to the next thing and then keep calculating. It's like you have to do it every single time. That's just lame. So you started with nothing. You deposited 1,000. You have 1,000. You put it into the equation and subtract 1,000. You get 40. And then you add it to the principal right here, and you get that. Now you grab the ending balance and start over again. Do exactly the same thing. You have this because you're adding $1,000 every year. Now you have 2,040. You're going to do the equation with this one, not with the principal anymore. You add that, and you get that one over there. Actually, you don't. You do it with 1,000. Sorry, you do it with 1,000 times 1 plus 0.04, and now you're gonna use this one for the rate, 2, and subtract 1,000, and it gives you that. Add it to this, and it gives you that over there. So you're gonna grab this guy over here again, bring it over here, add a new 1,000. Now you have this, and now you can do this thing again, but with 3 on the top, and that should give you a number. Take away 1,000 and give me that number. So basically do this, but with a 3 for the third year. The term. I'm surprised I ended up with it. All right, so for this one, you multiply 1,000 times 1 plus 0.04 to the power of 3, and I get 1,124.86, right? You take away 1,000 and you get whatever the interest was, which is only 124.86. You add that to the whatever you have now, and it gives you 230,246 and 86 cents, right? 3,246, 46, not 86. What am I saying? 46, right? Is that what you got? Well, guys, you adding the interest to the new value. So you add those two, and it gives you a new balance, an ending balance. It is, but this one is only the interest, not the total, not the interest and the principal. It's just the interest. So where does that number go now? Over here, right? Now we transferred over here 3,246.46. We add 1,000. We end up with 4,246 and 46 cents. Now we calculate that using the same thing, 1,000 times that, but now we use 4, right, for the term. And that gives me 1,169.86. But I take away the 1,000, right? Dang it. Yeah, so I end up with 169.86, yes. Yeah, you're supposed to be using the same thing all the time, yes. You take away 1,000 at the end. All right, so when you add those two, you get a new ending balance of 4,416.32. What? You did something wrong. Guys, you're using this formula over and over again. The only thing changing is the number on top, which is the term. So for term 1, you do term 1, term 2, 2, 3, 4, and so on and so forth. That's the only thing that's changing. And then the other numbers are just being transferred back and forth. So that we end up with now 4,416.32. Add a new 1,000, you get 5,416.32. And now we do again the same thing with this formula up here that I keep putting arrows on. But instead of using 4, what do you use? 5, because now we're on the 5th term. And take whatever you get from 100 and from 1,000, and you get 216.65. So then you add your new value, and you get 5,632.97. That's what I got. I said 97. You're deaf. And that's all I did. Yeah. So it is a lot of stuff. Yeah. The formula? Yes, guys, the formula will always be given, and you will have it on the formula chart on the star, for sure. So questions like they might ask you, how much interest have you earned by the end of the third term or third year? Or they might ask you, how much more interest would you earn on the third year, after the third year, using compound versus simple? So let's look at those. That was compound, right? For the end of the third year, we have made $3,446, $246.46. Write that down. $3,246.46. That's our total. That's our what we've saved and our interest. So how much interest have we earned so far? This is not good. How much this guy is like, what? Am I in class today? How much interest have we earned after the third year? What? Well, you could say that, but it's not really true. It's $246.46 because you're only depositing $1,000 a year. You're not depositing anything more than that. You're getting more interest. The thing is that on the simple, you're only getting the interest out of 1,000 every single time. On the compound, you get an interest whatever you earn, and it goes back into the account, and now you're doing it out of this one, not the other one. So that's why this one increases more. So on this one, we have made $246.46 after the third year. Yes. Match it with theirs. For us, they only made $120 for the simple one after the third year. So there's a huge difference between simple and compound. All right. I will have you complete that for homework, the whole table. And number 3, when? Yeah. The what? Yeah. And also do number 1 and number 2 of the independent practice, only those two, on page 451. Slow anything. What are you talking about? For the next part, we're going to talk about. Are you ready? Thank you. About store value cards, gift cards, debit cards, and credit cards. As I explained on my other period, we have more time somehow. A gift card are different than a store value card. For example, this is a gift card, but it's store value. Basically, I can only use this at Walmart. I cannot use it anywhere else other than Walmart. That's it. Taylor. Later. If I get a Visa gift card, that is a different story. Yes. Yes. Anywhere that where Visa is accepted, you can use that one, or MasterCard. This one is only for Walmart. And the other one type of payment, for this one, do you have to have money in it to use it? For the gift card? Well, duh, I'm going to use it, right? And then we have credit cards. Usually Discover is a very well-known one. So, credit cards, do I have to have money in here? Does this have money? What does it have? Credit, what does that mean? So it's a loan, right? This card right here is a loan. This card right here is actually the biggest problem in America. This is why a lot of people are broke. Because it gives you a limit of how much you can spend. And most people, not most people, a lot of people spend more money than they can afford, and they have to pay it back. So for example, this card, which is not mine, has a $15,000 limit. That means you can spend up to that amount of money, and it'll still work. You have to pay it back, though. It's just the limit that it has. And then you have to pay it, well, you're supposed to be paying it in 1 month. Otherwise, you get interest and you get fees and all that stuff. But that's the problem. People just go and swipe it, and they don't pay it on time, so they end up with all this debt. So we have a lot of debt in America. The other one, so this one is basically a loan. I'm borrowing money from this card. The other one, which is the debit card, do I have to have money on that one? I must have money on that one, otherwise I cannot use it. And some banks will let you use it if it's very close to the limit, but if you go over the limit, meaning you spend all your money. Let's say, for example, I have $100 left on my account, and I pay for $110. It'll be -10, and they'll penalize me for using the card when they didn't have enough money. That's called an overdraft fee, and every bank has that. It'll take it away. Yes. So yeah, you can. If you know how much money you have at this, like when you get to the store, many people do that actually. They'll pay whatever they have on the card, and then the rest of it in cash, just to make sure that you don't go over the limit. People have done it before, but it's just like circulating debt, because now you have another debt over there. It's not good. For example, car loans, you should be allowed to pay with credit card, but here's what happens. When you have a car loan, you're paying for your car, you're asking a bank for a loan. So you're already borrowing money. If you make your car payments with a credit card, you're actually paying with another loan. So it's kind of like recurring loans. It's kind of crazy, but people do that all the time. Like my tuition, I got a loan for it, but I'm paying that loan with a credit card, which is more debt. But that's how it works. Okay. Let me see which one I gave the other kids. Yeah. This one, number 7 and number 8 for 456. And that's all, wait. And the explore the activity. I know, Wayne. Yes. Huh? Guys, it's about 6 problems total. Page 456. This right here, your turn, 7 and 8. And the guided practice. Ask your friends. This is your example. If you're watching the video, shows you that. Basically, well, never mind. We'll go over this tomorrow. But this is fairly easy. It's asking you whether you have enough money or not.